Welcome everyone to the study guide review video for the 8th grade Unit 1 test. In this video I'm going to go through a question that's similar to every single question on the test and explain how to do it. So if you understand every question on this video, you can do it independently, then I'm sure you'll get every question right on the test. Alright, question 1. The point 3, -2 is shown on the graph. What are the coordinates of the image of this point after a reflection using the y-axis? Okay, so first we have to identify what the y-axis is. That is the vertical up and down axis here. And if we're going to reflect this point across the y-axis, first we want to see how many units away is it currently from the y-axis. So it's 1, 2, 3 units away to the right of the y-axis. So we're going to keep the same vertical distance and then just go 3 units to the left of the y-axis. 1, 2, 3. Okay, and then where we land is right here, and that is the point -3, -2, right? Because we're down here, -2. And remember, when we were writing a point, it's the x coordinate, comma the y. The x is left, right, and the y is up, down. So the answer is -3, -2 there. Okay, so you want to make sure you know how to plot a point and label a point that's plotted, and also reflect over either the x or the y-axis. You can use tracing paper for this as well. Question 2, determine the measure of the missing angle, angle ABC. So here we have this triangle, and we have 2 of the 3 angle measures. We learned in class that in any triangle, the sum of the angles is going to be equal to 180 degrees. Okay, so based on that, we just have a subtraction question, right? We have that 50 plus 45 plus question mark is 180 degrees. So you can write this out lots of different ways. 95 plus question mark is 180. So we just need to just subtract. When we do this, okay, we're going to get 85 degrees. So the measure of angle ABC has to be equal to 85 degrees. You don't have to set it up like this. You just ultimately have to add 45 and 50 together and subtract them from 180 to get this missing angle. Cool. Alright, question 3. Amari and Eva each made a design using 4 triangles. Select all of the true statements. First, we have the largest triangle in Amari's design is congruent to the largest triangle in Eva's design. Okay, so this question is really about our understanding of the word congruent. So we know in congruent shapes, they are the same size, right? So they have the same height, length, width, etc. And the same shape, which means they have the same angles. So here, we look at the largest triangle, in Amari's, and the largest in Eva's. We should see that they are the same height, they are the same base. If we wanted, we could use tracing paper and trace one, and you should see it would perfectly line up. So yep, that's going to be true. The largest triangles are congruent. Then we have each triangle in Omari's design has a congruent triangle in Eva's design. Okay, so looking here, we want to put at those individual triangles. So here's a triangle in Omari's, and then we can find this one that's congruent to it in Eva's. Again, that's the same height, the same width. We could use tracing paper, trace it, and it would line up. Then we have this one and this one. Those are, again, the same height, the same width. And then this one and this one. Again, the same height, same width. Those are the same triangles. Now, they're not arranged in the same way, but if we're saying each triangle, like we just specify just those small triangles, is congruent, then that is going to be true as well. Okay? If you translate Amari's design 10 units to the right, you get Eva's design. Okay, so looking at this, we should be able to see that that's not true. Okay, if I'm taking that and I'm sliding it over, it doesn't perfectly line up. Again, the outside does, but the designs aren't the exact same. So these are not the exact same, so the actual, it's not a translation for the whole design. The individual triangles could be, but not the whole design. And then for the same reason, Amari's design is not congruent to Eva's design, because if it was congruent, it would be literally the exact same, right? And it would match up if we traced it, but that's not the case here. Cool. Question 4, is shape A congruent to shape B? Explain your reasoning using translations, rotations, and reflections. Alright, so here we're trying to show, are these the same shape, the same size, the same angles? This is going to be another situation where tracing paper is going to be really helpful. So I encourage you to use it on the test, and when you take the MCAT and everything, you'll have access to it. Okay, it's a really good tool. So we can take it, and then we would need to spin it around. Okay, obviously it shouldn't change size, but there we go. So it looks like it perfectly matches up. We can check that, right? Like this is 2, this is 2, this is 2, 2, 2, 2, right? So all those side lengths are the same. Okay, so what did I do? If it's asking, is it congruent? I'm going to say, yes, it is. And then we could say like, oh, it's the same shape and size, but it says explain using translations, rotations, and reflections. So we know that two shapes are congruent if you can map one onto the other using translations, reflections, and rotations. So what did I do to get this here? I rotated it. Okay. And then depending on sort of your definition, translated it as well, depending on what you make the center as rotation. So this doesn't say like you have to give the explicit thing that happens. So if you just said you can rotate to get from A to B, that would be good enough credit. But we can be the most exact possible here. So like, yes, if you rotate 180 degrees around that point, A maps onto B, so they must be congruent. Okay, or if you just say like a sequence of rotations and translations or whatever would map you from A to B, I would accept that for this question. There's one later you'll need to be more detailed, but that would be good enough for this. So this is asking the same thing. Are these congruent? And explain using translation, reflections, and rotations. So tracing paper would honestly be better than what I have available to me using this on my iPad. But if I have this, I rotate it, and then it like kind of looks aligned there. It's like, okay, maybe I just need to reflect it. But this isn't going to mirror in quite the right way. It's not going to perfectly align. And the reason for that is here, it's like this is the tall side, but it's also the wide side. And if you look on here, this is the tall side, but it's also the thin side. So they're not actually the same shape. And again, tracing paper will illuminate that even more clearly, but it's not going to match up when you translate, reflect, or rotate, so these are not congruent. Okay, so I'm going to write that. Okay, is it congruent? No, there's no sequence of translations, reflections, or rotations that maps A to B, because they're not the same shape. Thus, they are not congruent. Okay, remember, saying they're not the same shape is like showing me you understand what congruent means, but it's not answering this question because we want to understand congruent means also that translations, reflections, or rotations will take one congruent shape to another. Okay, and that's like why it's in this unit. Cool. Question 6. Write a sequence of rigid transformations, including all necessary detail, to prove that polygon A is congruent to polygon B. So here, unlike these questions where I said you could just say generally you can get from A to B to rotate, here we're saying, okay, this is congruent, I need you to prove it with all the detail for the sequence that takes me from A to B. There's two main ways to get from A to B. So I guess I read them both, but you'd only need to have one. Okay, so one possible sequence is you can rotate triangle A 180 degrees clockwise or counterclockwise, it won't actually matter, around the origin. Okay, if we rotate this 180 degrees, try that again, rotate this 180 degrees around the origin, you'll get it to perfectly line up. The other thing that you could do, this is just like a second correct answer, is you could reflect A over the x-axis and then again over the y-axis. So that's just sort of like a fun fact, is understanding. It is important to know that rotating 180 degrees is equivalent to reflecting over the x-axis, which would look like this. Okay, and then reflecting over the y-axis. So either answer there would work. There are other answers too, but those are like the main ones. As long as you give me some sequence of translations, reflections, and rotations that takes A to B with all necessary detail. So we have the degree, the direction, and the center of rotation, or the lines of reflection, then you'll be in good shape. Alright, question 7. Lines AB and CD are parallel. Determine the measures of the three angles in the diagram. Alright, I like these questions. They're like puzzles, but can be a little challenging. So these two lines are parallel, and we're given some of these degrees, and we need to figure out the measures of the other. Okay, so remember when we have parallel lines cut by a transversal, so here's a transversal to my pink lines, we have lots of rules. So like this angle is 37 degrees, they tell us. So that means this angle, which is its vertical angle, is 37 degrees. But we also know that we can like translate this 37 degree angle up, and this angle that's formed is also 37 degrees, and then vertical angles here, that angle is also 37 degrees. Okay, so when we have these parallel lines, those pink lines here that are never going to touch, cut by a transversal, just a line that's cutting through two different lines, we have all these pairs of congruent angles. So all for this, 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 and this are all 37 degrees. Okay, that's one. Alright, then we want to find this one. So for that, I'm going to sort of like get rid of this line. Here, I have this line, and in that line, this angle is 149 degrees, and I'm trying to figure out what this is. But I know that those two angles form a straight line. And when we have a straight line or a straight angle, okay, that's 180 degrees total. So question mark here plus 149 has to equal 180. So then again, like we did in question 2, we can subtract 180 minus 149 is going to be 31 degrees. So this is going to be 31 degrees. Okay, and then finally, now I want to figure out what this angle is. Now that I have used those properties, the last one is what do we know about triangles? So we also know that triangles, the sum of angles is going to be 180 degrees. So in this triangle, I know that one of my angles is 37 degrees, one is 31 degrees, and then I'm trying to figure out what that last one is, but I know the sum, again, has to be 180. So however you want to do this, you will have a calculator, so you're welcome to use it, but also you should be able to do this without a calculator. You can add up those angles, 31 plus 37, that's 68 degrees. Subtract that from 180, and we'll get 112 degrees. So it's definitely one of the harder questions, but just getting these key ideas, parallel lines cut by a transversal, these are all going to be the same. Here, it's 180 degrees in a straight line, so we can subtract. And then in pink, there's also 180 degrees in a triangle. Beautiful. Okay, last page. Question 8, the pre-image on the left is reflected across line K. Sorry, that should be K. To form the image on the right, use the information in the original figure to label the corresponding parts of the image. Length measured are in grid units. Okay, so all we're told is this is a reflection, but what we know is when we have a reflection or a translation or a rotation, these are going to be congruent. So all the angles are going to be the same, all the side lengths are going to be the same. So if you want, you could use tracing paper to trace that, but you're just going to say, like, what are the new angles going to be? So this is 90, and this is 90 degrees. Those would match up. This point and this point would match up. So this is 120 degrees. This point and this point would match up. They're corresponding, so that's 100 degrees. This point corresponds with this point. So this is going to be 140 degrees. And then we can do the same thing with the side lengths. Okay, this is 1.8 units, so that's 1.8 units. This is going to be then 2.3, this is going to be 2.5. And then we can also label these because these are just nice whole. That's 2. That's 3. Okay, so you're just labeling all those parts. The point of this is you can see how the corresponding points line up and the corresponding angles. And we also just understand this key fact about congruent figures is that all the angles are going to be the same and map onto each other. Okay. 9, explain why B cannot be the image of figure A after a reflection. Okay, so for this, looking at it, we want to say, okay, well, it kind of looks reflected, right? I mean, it doesn't look like a rotation or a translation, but then if you look closely, we have this, okay? And if we compare it to that, those are not the same. And we know that, again, reflections, like I just said, and rotations and translations give us congruent shapes. So the image of A after a reflection should be congruent to A. But B is not the same shape. So B cannot be the image of figure A. The reflected image of figure A. Okay, because they're not the same shape. Awesome. And then finally, select all of the following sets of angles that are possible for a triangle. So again, this is testing our knowledge of the fact that in triangles, the angles sum or add up to 180 degrees. So all we have to do is add these three in each of them, and then just the correct answers are the ones that sum to 180. So 10 plus 20 plus 30, that's 60 degrees, so that's not right. 45 plus 90 plus 45 is 180, so that's right. 178 plus 1 is 180, so that's correct. 30 plus 50 plus 20, that sums to 100 degrees, so that is not right. Okay, that can't be a triangle. And then 100 plus 40 is 180 degrees. So again, that one can be right. So all we're doing for that question is adding up the angles. The sum needs to be 180 degrees. Cool. Alright, I think you guys can do well on this quiz. Studying, it's good you watch the video. Make sure you're trying the problems yourself too, and you redo any problems that you didn't understand the first time. Good luck, everyone.